Hi Amanda. We're going to start here with P1. So P1 is to find the similarity ratio. So what that means is that we're trying to figure out the scale factor, how we get from one shape to the next. So we have to look here at what the order of the images are. The question is, what is the similarity ratio of RST to triangle HIG? So what you do is you divide the original to the new. So we have here that RS is going to correspond to HI. So what you do is 2 divided by 6, which if you do 2 divided by 6, that's a decimal. But it doesn't want it in the form of a decimal. It says here to write it as a proper fraction, improper fraction, or whole number. So we want the fraction. If we do 2 over 6, that can be simplified to 1 over 3. So that would be the ratio. Let's try this one now. We have TUV to FED. So we find corresponding sides. TU would correspond to FE. So we do 6 divided by 2 is 3. Here we want to find the similarity ratio of GHIJ to FCDE. So here you can pick whatever sides you like. GH would correspond to FC. So we do 2 divided by 4, or 2 over 4, which can be simplified to 1/2. Here it says EFG to BCA. So EF is going to correspond to BC. So we do 2 over 4, which gives us a simplified fraction of 1/2. And that's P1. Let's go to P2. In order to write a similarity statement, it's the same thing as writing a congruency statement. Your corresponding sides must be written in the same order. So if this is going from X, Y, Z, see how it goes from the 28 degrees to then 76 and 76, this is going to be to TUS. Here we have QRST. So we have to look here. QR is the short side. So I would start with the short side and then go around. So UVWX. This one is TUV, very similar to the one that we did at the beginning. So T is 28, so I'm going to start with E, and you can either go DF or FD since those are the same angles. So we're going to do EFD. Here we have STUV. So it starts with the long side of the rectangle. So we have to start with the long side of the rectangle and then go around. So we can say that STUV is similar to HEFG. We'll do one more because this is just basically the same thing over and over. Here we have GHI. Now these angles are all different. So we have to start with the 45 degrees. So 45 degrees, so that corresponds with W. Then it goes to H, which is 78. So that means I got to go to X, which is also 78. And then lastly, V. Okay, we'll just do a couple more. Here we have VWXY. V is the 59 degrees. That means that E and C are also 59 degrees. Since two shapes, when they're similar, their angles never change. So all of these angles would be the same. So these here would be 121, just like these. And these that are 59 would make these here 59. So if I start with V, I would have to start with either E or C. So here it goes VWXY. So I'm going to go EFCD. Let's try this last one here. We have HIJK. So starting with the 129 degrees and then working our way around. Either S or Q are 129 degrees, so we can start with whichever one. Let's say I start with Q. Then it would be QPSR. But then here it also tells us what is the similarity ratio. And that's where we take the corresponding sides and divide. 8 divided by 2 is 4. Here we have BCDE. So it goes from the base angle of this trapezoid. So we can start here. It goes B and then it goes through the short side here. So if I start with T, I would have to go up to S. Or if I start with Q, I would have to go up to R. So BCDE would be QRST. And the similarity ratio would be when we divide, just like in the previous IXL. So you pick corresponding sides. Let's say I choose this one with this one. 16 divided by 8 would be 2. And that's P2. Let's go now to P3. In order to figure out if the shapes are similar, you have a couple things. The angles must all be congruent to the other triangle. You see you have 1 arc, 2 arc, 3 arcs, 1, 2, 3, so all is well. Then their corresponding sides must be, must be proportional. So we would have to make sure that all of the ratios are going to be equal. So I'm going to go ahead and copy this diagram so we can work that out. Whoops. Okay, let me do that over here. One moment. Okay. So HIJ, if it's similar, I like to write the order for that way I know what sides correspond with what. Starts with H, so this is going to start with P and then QR. So that means that HI, 28, has to be proportional with PQ, which is 21. We can simplify this by 7. 28 divided by 7 is 4, and 21 divided by 7 is 3. Then we do the same thing for the other sides. So this is between the 3 and the 2, so that's 24 over 3 and the 2, which is 18. Both of these can be simplified by 6. 24 divided by 6 is 4, and 18 divided by 6 is 3. So far everything looks good, but we're going to check this last one here. So these short sides. So 12 has to be proportional with the 9. Both of these can be divided by 3, which would give me 4 over 3. Since they all share the same ratio, that means that yes, they are similar. Now we're going to do the same thing here. Between the angles 1 and 2, we have 40, and then it goes to 32. So we have to check if that's similar. So let me copy this one over. So we're going to create the ratio 40 to 32, both of which can be simplified by 8. So 40 divided by 8 is 5, and 32 divided by 8 is 4. Now we do 50 here, which would correspond with the 40. So we would put 50 over 40, both of which can be simplified by 10, which would give us 5 over 4. Then these are the same, so we don't have to do those because those are going to share the same ratio. So since everything has a ratio of 5 over 4, that means that yes, these figures are similar. Now here, look at this one. We have this square. Everything is 25. That means if this was similar, everything would also be the same because the shape does not change, just the size. But now that this side is 26, that makes this a rectangle and not a square. So since they are technically different shapes, these would not be similar. Over here we have this rectangle. If we create the ratios of the small sides, we have 25 over 24, which cannot be simplified, so that's the ratio. If we create the ratio for the long sides, we get 35 over 35, which is 1, which is not the same as 25 over 24, so no. Now here we notice that we have a parallelogram. All sides here are equal. All sides here are also equal. So if I create the ratios, these would all be equal ratios. So that makes this similar. Now here we have a trapezoid. We're going to have to create these ratios to see if everything matches up. Now if you just kind of do a scan, if you do 24 over the corresponding side, which is 22, you would get, I'm just going to write it here, 24 over 22 would give me 12, if I divide everything by 2, over 11. So that's the ratio, and everything should be 12 over 11. If I do the diagonals, we have 26 over 32, which 26 over 32, everything can get divided by 2. 26 divided by 2 is 13, over 32 divided by 2, which is 16. This is not the same as 12 over 11, so you don't need to keep going since they don't have the same ratio, so no. Now here we have where a square. All of these are equal. In order for this to be similar, this would also have to be a square. But we see that these are rectangles, or it's a rectangle since we have these two short sides and these two long sides. So if I create the ratio, I would have 47 over 34 and 47 over 47, which is 1. So no, these would not be similar. Last one here, we have this parallelogram which all has equal sides. If they are all equal, then this one should also have all equal sides to make sure that the ratios would be equal. These two sides are equal, but these two are not. So that means that the ratios would not be the same. So no. Now let's go to P4. If you're trying to find the length of a side, you have to determine the similarity ratio. So here we can see that the orientation is the same. WU corresponds with BC and UV corresponds with CD. In order to get from 2 to 8, we would have to have multiplied by 4. So if I want to find UV, since CD is 16, if I divide by 4, that's going to give me UV, which would be 4. Because if I multiply that similarity ratio, 4 by 4, I would get the 16. Now the angle measures, those you don't have to do anything. They should all be equal. So these two here are 48. And if this angle is 84, that means that this angle must also be 84. Here we have these two triangles. And you can also use the similarity statement that's given at the beginning. WXY is similar to EDC. That means that angle W corresponds with angle E, and the angles should be the same. So if E is 41, W is also 41. Here I want to find the measure of angle F. If I look at my similarity statement, angle F is corresponding to angle A. And if angle A is 47, that means that angle F is also 47. Now here we're looking for these side lengths. We have here that DE is 38, and DE is going to correspond with HI, which is 19. In order to get from 38 to 19, you would have to divide 38 by 19. So that means that 19 times 2 is 38. That means that to find DF, we find its corresponding side here, which DF is going to correspond with HG, which is 16. And since the similarity ratio is 2, we are going to multiply 16 by 2. Since 19 times 2 is 38, so we multiply all of these here by 2. So 16 times 2 is 32. And 12 times 2 is 24. Okay, now here we have where we're trying to find the angle measures. If FGHIJ is similar to YXWVZ, that means that all of their angles are going to be congruent. The measure of angle V, if I look here at my statement, corresponds with angle I. And angle I is 111. So that means that angle V is 111. Then if we're trying to find angle H corresponds with angle W. So they will be the same. So angle H is going to be 126. Now here I'm trying to find the length of CE. CE corresponds with WY, which is this 30. Now what we're given here in this triangle is CD, which is 4. CD corresponds with WX, which is 40. In order to get from 40 to 4, we would have to divide 40 by 10. So that means that the similarity ratio is 10. So if I want to find CE, that means I take the one here, CE, which is WY, which is 30, and divide by 10, which is 3. Last one. We are looking for HK, which is this small side here. Now we need to determine that similarity ratio. In order to get from 2 to 18, because these sides here correspond, we had to multiply by 9. But since we're going backwards, because we're trying to find HK, that means that 18 divided by 2 is 9. So I would have to divide by 9. If I want HK, HK corresponds with UV. And UV is 9. So 9 divided by 9 is 1. Then HI, which corresponds with UT, which is 18. 18 divided by 2 is 9. Oh, whoops. Sorry, I did 18 sorry, it's 18 divided by 9, which is 2. Sorry about that. Let's just do one more just to make sure then. Okay, so we're looking for these angle measures. Y is going to correspond with F. And since F is 40, that means Y is 40. Angle E corresponds with angle X. Since X is 53, E is also 53. Okay, let's do this last one here. We want to find UV and UW. So here we have this triangle and we have VW. By looking at the similarity statement, VW corresponds with CD. To get from 3 to 27, we had to have multiplied by 9. So that means that in order to find UV, UV corresponds with EC. EC is 5, so we multiply by 9 and get 45. UW corresponds with ED. ED is 4, so multiply by 9, we get 36. And that's P4. So let's go to P5. Here we have that triangle QPO is similar to SPR. So this is going to be the same thing as what we did in the previous IXL. In order to find Z, which is QP, corresponds with SP. So what we do is we have to figure out what is the similarity ratio. In order to get from 10 to 5, because we have to use the other sides, from 10 to 5, we had to divide by 2. So that means to get Z, we would have to take the 8 and divide by 2, which is 4. Here we want to find R. Now, we have this little triangle that is inside of the larger triangle. So the little one here is going to be similar to the big one here. So that means that HJ, the 3, is going to correspond with the R. And this little side here, the 4, is going to correspond with the long side of the triangle, which is 8. So since I'm trying to find the big one, in order to get from the small 4 to the large 8, 4 to 8, we multiply by 2. So 3 times 2 will give me that R is 6. Here we're trying to figure out K. K is going to correspond here with the 4. And we look at the other sides to figure out what is that similarity ratio. Since I have to go from big to small, I like to look at the big to small to see what I had to do. In order to get from 6 to 3, I'd have to divide by 2. So in order to get K, you would do 4 divided by 2, which is 2. Here we want to find J. So same thing. J is going to correspond with the 6. That means that these here correspond to each other. In order to get from 10 to 5, we had to divide by 2. So in order to get from 6 to J, we have to divide by 2. 6 divided by 2 is 3. Here we have these two triangles. It says here in the similarity statement that IJK is similar to LMK. And we want to find P. If we look here, P is going to correspond with this 39. That means that IK is going to correspond with LK. So we're going to have to figure out what is that similarity ratio. Now, this one is kind of difficult because it's not as easy as the other ones. So I'm going to copy this over and we're going to work it out. So this corresponds with this. So I'm going from small to big. So I would write 51 over 68. And that has to equal to the ratio of these two sides. Since I went small to big, I got to go small to big. So 39 over P. If you're trying to solve for P, what we do is we cross multiply. So we have 51P is equal to 68 times 39. which 68 times 39 is 2,652. So to solve for P, we would divide the 51. And when you divide that by 51, you get that P is equal to 52. So that would be my answer there. Now let's look at this one. We're trying to find H. Now it doesn't tell us the similarity statement, but that's okay because we have this small triangle that is inside of the large triangle. So that means that this 12 is going to correspond to the 16. And this H is going to correspond to the 12. So we can create our ratio. So I'm going to copy this so we can go ahead and do that. So we're trying to solve for H. I'm going to go small to big. So H over 12 is going to equal to, and then I use these corresponding sides, small 12 to 16. So now we multiply. H times 16 is 16H is going to equal to 12 times 12, which is 144. Divide the 16, and we get 144 divided by 16, which is 9. So that's how we solve these. We have to create the equation and then cross multiply. So this answer is 9. Okay, I'm just going to go ahead and, well, this one we can do without. So here we're trying to find V. If you notice that V is corresponding to the 4 and 5 corresponds to the 15. Since we're going from 4 to V, which is small to big, I'm going to go small to big. 5 to 15, I would have to multiply by 3. So that means that to get V, we do 4 times 3, which is 12. So V is equal to 12. Last one here. We want to find W. Now, W is this straight side here, which is going to correspond with this side here. That means that these two would correspond to each other. So I'm going to copy this so that we can create that ratio. So I do the ratios when I can't automatically figure out what is the scale factor. But if I can figure out what was multiplied or divided, then I would just go that route. So W corresponds to 45. So I'm going to go big to small. So W over 45 is going to equal to, and now we use the other corresponding sides. Since I went big to small, I have to go big to small again. So 68 over 51. Now we cross multiply. W times 51 is 51W is going to equal to 45 times 68, which is 3060. And then we divide by the 51. And we get that W is going to equal to 60. And those are all of those IXLs.